Let's review what you should know about the continuous random variable and probability density function. First of all, the probability density function exists only for continuous data and doesn't exist for discrete data. And it's such a function, for example, f of x shows that probability that x is greater or equal than a and less or equal than b is equal to integral from a to b f of x dx. And we know that integral is area, so area under the curve within a and b is equal to the probability that x is in between a and b. And notice that it doesn't matter endpoints are included or excluded, it's also the same integral. It's because probability that x is equal to some specific value is equal to 0. So if you need, for example, probability that x is greater than a and less than b, it will be the same integral. Or, for example, probability that x is greater or equal than a and less than b, it's also the same integral. And we know that total probability is 1, and here it becomes integral from negative infinity to plus infinity. It means over all possible values of x, f of x dx is 1. For example, for this problem, it becomes integral from 0 to 2. This function is 1. Let's consider the next example. It is given the probability density function. Sketch the graph of x for x is in between 0 and 2. This problem is with a calculator, so you can use a calculator and get the graph. And we can see that it's just increasing function. So it looks like this. Y values are not important here. And how to find mode? Definitely, if you use a calculator, you may write some scale on y-axis or write this y value. But if we consider the mode, y values are not required, and by definition the mode it's such x value which has the greatest value of the probability density function. And if function is always increasing like this, hence mode is just x is 2. It may be that the probability density function looks like this, and in general to find x value which is the mode, we need find a turning point, and so we find derivative, equate it to 0 as usual, and solve it and find the corresponding x value. The next, find the mean of x. Mean, or it's the same as expected value of x, is denoted as e of x, or maybe just mu, and is equal to formula is given in a data booklet. It's integral from negative infinity to plus infinity f of x multiplied by x dx. And for this example, it becomes integral over all possible x values from 0 to 2. And notice that if in general it may be piecewise function, so you should consider a sum of integrals over each interval of x values. So here it becomes integral from 0 to 2 x multiplied by f of x, so it's x squared over 6 multiplied by 1 plus x squared dx. And this problem is with a calculator, so you can easily calculate it and get 68 over 45, or 1.51 to 3 significant figures. It's not required here, but let's consider how to find variance or standard deviation. Variance is equal to standard deviation squared, so if you know variance you can calculate standard deviation, or vice versa. and it is given a formula in a data booklet that variance is equal to expected value of x squared minus expected value of x, or mean squared. Expected value of x is this, and what is expected value of x squared? It's integral from negative infinity to plus infinity over all possible x values x squared multiplied by f of x dx. And the next, how to find median. We know that median is such a value of x so that 50% of data don't exceed this value, and for continuous it becomes integral from negative infinity to m, and m it's the required x value, which is the median, f of x dx is equal to 0.5. Area is 0.5. And similarly, lower quartile, upper quartile, or any percentile can be found as, for example, lower quartile, it's 25th percentile, it's integral from negative infinity up to some value, that would be q1, f of x dx is 0.25. and so on. Q3, 75th percentile, it's integral from negative infinity up to some Q3, for example, f of x dx is 0.75. And here, since x is from 0 to 2, and here it becomes integral from 0 to m x over 6 1 plus x squared should be equal to 0.5, and if for example problem without a calculator, you just calculate this integral, when you substitute limits you get equations, solve for m. But if it's with the calculator, we do it with the calculator, and we cannot solve it directly using equation or on a calculator. We do it with the graph, and we can consider this to be one function and this to be another function, and we find point of intersection. But I prefer to consider one function, so we move 0.5 to the left and consider only one function, which looks like this, and it is equal to 0. So it becomes we consider the next function, integral is here mass, and integral it's this one, integral from 0 because for this problem x is in between 0 and 2, so it starts at 0 up to x. X is variable here, our function minus 0.5, and we need x intercept or 0 over given function. And we know it's important that y0 is included, so let it be, for example, y from negative 2 to 5, it doesn't matter, y0 should be included. For x values, since here it's from 0 to 2, let it be from 0 to 2, and we get the next graph, and then calc, and we need 0, and left bound it's somewhere to the left, the right bound move to the right from this point, which is x-intercept, can be somewhere here, and guess, and we get the result 1.61 to 3 significant figures. So median is 1.61 to 3 significant figures. When function is piecewise, this problem becomes more complicated. If, for example, it looks like this, you need to find area, this area. For example, if the first because there are two functions, f1, f2, you find this area, and if this area is greater than 0.5, for example, if this area is yes, if it's greater than 0.5, for example 0.6, you understand that median is to the left. So this to find median, we consider integral from 0 to, if it starts from 0, because in general it may start from another point, to m f1 dx is 0.5, because if this area is, for example, 0.3, you understand that your median is somewhere here. But since it's piecewise function, you should consider the next. You should find this area firstly, if it's 0.3. For example, you understand that median is here and this area is 0.2. So it becomes integral from this x value to be some. You can clearly understand what this point is, because if it is given as piecewise function, it's always specified region. So it becomes integral from a to median f2. So it's already the second function. Dx it should be equal to 0.2, because hence you get total area B equal to 0.5. And that's all for this question.